Hello everyone, welcome to another video on time, speed and distance by THiNC Institute of Design. My name is Jackson. Let's get moving. So when we talk about time, speed and distance, this is something which is very much connected to our daily life. So we usually travel to certain places, we usually plan it accordingly, like how much time which will it usually take to reach at the destination, at what speed we can move, and how much distance we have to cover. So these are all things which we usually think of. And time, speed, distance is all about finding out the distance, the speed, and the time which we usually cover or take for covering a particular distance. So, before jumping in, let me just tell you one thing, one basic formula, that is distance equals speed into time. You all might be knowing it. Let's say a person is moving at a speed of 40 kilometers per hour for 3 hours. So total distance travel will be 40 into 3, that is 120 kilometers. Or if a person is moving 120 kilometers at a speed of 60 kilometers per hour. So we know that distance is 120, speed is 60. So distance equals speed into time. So time will be distance by speed and speed will be distance by time. So this is basic thing. So a person is covering 120 kilometers at a speed of 60. You know the distance, you know the speed. So time is distance by speed. So we'll do 120 by 60, which is 2 hours. So based on distance equals speed into time also, we'll get some questions in the exam. So let's see how we can actually tackle a question. But before that, uh, see, this question can be done if you just know distance equals speed into time. But to make it a bit more fast, we have something else here. So when distance is constant, S1 by S2 equals T2 by T1. What does that mean? So a person is traveling a particular distance. Let's say this is a distance which you need to cover. And he is initially moving at a speed of S1 and let's say the time taken is T1. Now what is constant? Distance is constant. Again he is covering the same distance and let's say the speed is S2 and time taken is T2. So he is covering the same distance but at a different speed and the time taken is also different. Now what is constant here? Distance is constant, right? So distance is constant. So when the speed is S1, the time taken is T1. So we know that distance equals speed into time. So we can say that D equals S1 into T1. So distance equals speed into time. Now, the same person is covering the same distance D. When he covers it at a different speed, he is taking a different time. But again, when you multiply these two, you'll get the same distance because he's covering the same distance. But it is different speed and the corresponding time taken is also different. But S2 T2, when you multiply these two, you'll get the same distance. So D is equal to S2 T2 also, right? So a person is covering same distance at two different speeds, S1 and S2, and the time taken is T1 and T2 correspondingly. So S1 T1 is the distance traveled, S2 T2 is also the same distance traveled. So S1 T1 and S2 T2 are the same. So we can equate it up. So what will we get? S1 T1 equals S2 T2. Or if you keep all the S2 one side, S1 by S2 equals T2 by T1. So if distance is constant, we can write like this, S1 by S2 equals T2 by T1. Okay, so now let's see what happens when speed is constant. A person is moving at a certain speed for a time t1 and distance traveled is d1 in the first case. Now again, let's say this is d1. Now again he is moving at the same speed, but he is moving for another time t2. So now the distance traveled is, let's say, d2. This is d2. So what is constant in each case? Speed is constant in each case. So what is speed? It is distance by time. So speed in initial case is d1 by t1. In the second case also it is d2 by t2. So speed is constant, so d1 by t1 and d2 by t2 are the same, right? So we can write this as d1 by d2 equals t1 by t2. So d1 by d2 equals t1 by t2 when speed is constant. Now let's go for the last case. What happens when time is constant? Say a person is traveling for a time t. Initially he is moving at a speed of s1, so the distance traveled is d1. Let's say this is a distance. Now he is moving at a speed of s2 and he's covering a particular distance d2. But again the time taken to cover d2 is the same at a speed of s2. So what is constant in this case? time is constant. So what is the time in the initial case? Time is distance by speed. It is d1 by s1 in the initial case. In the second case, it is d2 by s2. So if time is constant, both are same, right? So we can write this as d1 by d2 equals s1 by s2. Is it clear? d1 by d2 equals s1 by s2. Actually, in the exam, we will not get this much time to derive when what is d1 by d2 and what is s1 by s2. All these, we can actually derive it if you have enough and more time. So keep this in your mind. If distance is constant, speed and time are inversely proportional. Why? A person is traveling the certain distance. If you increase the speed, the time taken will be less. If you decrease the speed, time taken will be more, right? So if distance is constant, speed and time are inversely proportional. That's why S1 by S2 equals the reverse, T2 by T1. But when speed is constant, a person is moving at a particular speed throughout. When he travel for more time, he can travel more distance. When he travel less time, he can travel less distance. So when speed is constant, distance and time are directly proportional. That's why d1 by d2 equals t1 by t2. In the same way, if time is constant, if a person is moving for a certain time and the time is constant, if he move at a higher speed, he can cover more distance. If he moves at a lesser speed, he can cover less distance. So if time is constant, distance and speed is also uh, they are also directly proportional. So d1 by d2 equals s1 by s2. So when speed and time are constant, these are directly proportional. That's why d1 by d2 equals t1 by t2 and d1 by d2 equals s1 by s2. But when distance is constant, these are inversely proportional. That's why s1 by s2 equals t2 by t1. I believe this is clear for you. So we have a question connected to the same. Let's identify what is constant in this and let's do the question. So all of you read the question very carefully. What is the question all about? A person went to office and returned back at two different speeds of 40 kilometers per hour and 60 kilometers per hour. A person went to office and then he returned back. So what is constant in this case? A person went to office and then he returned back. So what is constant in this case? Distance is constant, right? So what happens when distance is constant? S1 by S2 equals T2 by T1. Okay, let's see what happens. A person travels from home to office and then he returns back from office to home at two different speeds of 40 kilometers per hour and 60 kilometers per hour. So we know the value of S1, we know the value of S2. And he took 2 hours to reach office. Towards office, the time taken is 2 hours. At what time he will reach back if he left the office at 4 p.m. So if he left the office at 4 p.m., what time he will reach back is a question. So we need to find the value of T2. So how can we find the value of T2? So we know that distance is constant. He is moving towards office, then he is returning back. So if distance is constant, S1 by S2 equals T2 by T1. So what is S1 by S2? It is 40 by 60 and that is equal to T2 by T1. What is T1? It is 2. So T2 by T1, that is 2, right? We know S1, we know S2, we know what is T1. We need to find the time which he takes to return back. So T2 is what we need to find out. Now you can cross multiply. So what will you get? T2 equals 2 into 40 by 60. Now we can cancel this off. So what will we get? 4 by 3 hours. So 4 by 3 hours means how much minutes? So we got the time taken to return back, that is T2, that is 4 by 3 hours. Now what is the question? If he left at 4 p.m., what time he will reach back is a question. So what we have to find out, we have to convert 4 by 3 hours into minutes. So how can we convert hours into minutes? We'll multiply this by 60. So what is 4 by 3 into 60? We will get 80 minutes, right? Now we know that 1 hour is 60 minutes. So 80 minutes means 1 hour and 20 minutes. So he takes 4 by 3 hours to move back. 4 by 3 hours means 1 hour and 20 minutes. So that means if he left at 4 p.m., after 1 hour and 20 minutes, he will reach back. So 1 hour and 20 minutes after 4 p.m. means 5:20 p.m. will be the correct answer. So 5:20 p.m. is the time which he at which he reached back at the same point. So I'll just conclude this again. So a person is moving from home to office and returning back. A person is moving towards office and then he returns back. So he is traveling the same distance. So if distance is constant, S1 by S2 equals T2 by T1. You know S1, you know S2. Speed at which he moves is towards office is S1, returns back is S2. So 40 and 60. And T2 is what we need to find out. How much time will he take to return back? And towards office he took 2 hours. So T2 is what is missing. T1 we already know that is 2 hours. So we can cross multiply. So we'll get T2 as 4 by 3 hours. So 4 by 3 hours is what he takes to move back. 4 by 3 hours means 1 hour and 20 minutes, because when we convert 4 by 3 into minutes, we'll get 80 minutes. 80 minutes is 1 hour and 20 minutes. So 1 hour and 20 minutes after 4 p.m. he will reach back. So 5:20 p.m. will be the correct answer. So I believe this is clear for you. So this is a question where we make use of these concepts, where one is constant, what will be the relationship between the other two. Okay, let's get it moving. We are moving on to the next question. This is actually a slightly difficult question, but still there is a shortcut for doing it really fast. And this is a question which usually comes in for almost all the exams. Very repeatedly asked question, so we cannot skip it and move forward. So let's see how we can actually tackle this question. A person moves from home to office at a speed of 60 kilometers per hour and reaches the office 10 minutes early. So when he moves at 60 kilometers per hour, he reaches the office 10 minutes early. And if he moves at a speed of 40 kilometers per hour, he reaches the office 10 minutes late. So when he moves at 60 kilometers per hour, he reaches the office 10 minutes early. If he is moving at 40 kilometers per hour, he reaches the office 10 minutes late. So we need to find the distance between the home and the office. So basically imagine you are actually moving towards the office. If he moves at 60, you reaches the office 10 minutes early. If he moves at 40, you reaches 10 minutes late. And what we need to find out, we need to find out the distance between the home and the office, right? Very interesting question, right? So we just know the two speeds, and if he moves at 60, this person reaches the office 10 minutes early. If he moves at 40, he reaches 10 minutes late. We need to exactly figure out what is the distance between the home and the office. Now, the one way of doing this is using the options. So imagine the distance from home to office is 60 kilometers according to option A. So imagine option A is correct. So he moves from home to office at a speed of let's say 60 kilometers per hour. How much time will he take? So imagine 60 is the distance. So distance is 60 and speed towards office is 60. So time taken will be distance by speed, which is 1 hour, right? Now, if imagine he's moving at a speed of 40 and if the distance is 60, what is the time taken? Distance is 60 and if the speed is 40, so time taken will be distance by speed, which is 60 by 40, which is basically 3 by 2 hours or 1.5 hours, right? That means if he moves at a speed of, if 60 is the distance, if he moves at a speed of 60, he takes 1 hour. If he moves at a speed of 40, he takes 1.5 hours. Now, what is the difference in the time taken? It's zero point 0.5 hours or 30 minutes. Now, in this case, is there a difference of 30 minutes? In the first case, he reaches office 10 minutes early. In the second case, he reaches office 10 minutes late. For example, the correct time is 10 o'clock. When he moves at 60, he reaches 10 minutes early means he reaches at 9:50. Moving at 40, he reaches 10 minutes late means he reaches at 10:10 only. So between 9:50 and 10, what is the difference in the time? It's exactly 20 minutes, right? 9:50 to 10:10. So difference in the time taken in each case is need to be 20 minutes. But here, if the distance is 60, difference in the time taken is 0 0.5 hours or 30 minutes. So is option A the correct answer? No chance, because the difference in the time taken need to be 20 minutes. In the first case, he reaches 10 minutes early. In the second case, he reaches 10 minutes late. So difference in the time taken need to be exactly 20 minutes. But here, when distance is 60, he moves at 60, he takes 1 hour. When distance is 16, he moves at 40, he takes 1.5 hours. So here the difference in the time taken is 1 hour and 1.5 hours means difference is 0.5 hours or 30 minutes. So option A is not right. Now let's go with option B. Let's say the distance is 40 kilometers. So I'm assuming the distance between home and office to be 40 kilometers. Now if somebody moves at 60, what is the time taken? It is 40 by 60. That is 2 by 3 hours, right? This is the time taken in the initial case. So 2 by 3 hours means how much minutes? 2 by 3 into 60, that is 40 minutes, right? Now, if he moves 60 kilometers, 40 kilometers at a speed of 40 kilometers per hour, what is the time taken? So, time taken will be 40 by 40, that is nothing but 1 hour. So, 1 hour means exactly 60 minutes, right? So, if the distance between home and office is 40 kilometers, and if somebody moves at a speed of 60 and 40, the difference in the time taken is basically 40 minutes and 60 minutes. What is the difference? Exactly 20 minutes, right? So that is what we need. So if person travels a particular distance, if he moves at 40 and 60, in the first case he reaches 10 minutes early, in the second case he reaches 10 minutes late, means the difference in the time taken need to be exactly 20 minutes. And if you try with 40 kilometers, when he moves at 60 and 40, the difference in the time taken is exactly how much? 20 minutes. So difference in the time taken is exactly matching with what is given in the question. So difference of 60 minutes and 40 minutes is exactly 20 minutes, which is matching with the information given in the question. So option B will be the correct answer. But actually speaking, this might be a bit confusing for some of you, I believe. So I will give you another example. I mean another technique with which we can do it really, really fast. This is one way of doing it, that is we are making use of the options. Now, what is the next technique? I am assuming a distance from home to office. Let's say I am assuming a distance which is divisible by 60 and 40, let's say 120 kilometers. So imagine the distance between home and office to be 120 kilometers. So if a person moves at a speed of 60 kilometers per hour, what is the time taken? Time taken will be 120 by 60, which is 2 hours, right? And if a person moves at a speed of 40 kilometers per hour, what is the time taken? That is 120 by 40, that is 3 hours, right? So what is the difference in the time taken? What is T2 minus T1? It's 1 hour now, or 60 minutes, right? So if the distance is 240 kilometers, difference in the time taken will be 60 minutes. Now there is a particular distance this person moves at 60 and 40, which creates a difference of 20 minutes in the time. So if 120 is a distance, moving at a speed of 60 and 40, the time taken is 2 hours and 3 hours, and the difference between them is exactly 1 hour or 60 minutes. But there is a particular distance which this person travels at 60 and 40, which creates a difference of 20 minutes. So if distance is 240, difference in the time taken will be 60, right? So if the distance is 240, difference in the time taken is 60. Now there is a particular distance which creates a difference of 20 minutes, and that distance is what we need to find out. So how can we find it? So we know that when we move larger distance, so if the distance is 120, okay, let me just write it again. If the distance is 120 kilometers, difference in the time taken is exactly 60 minutes. Now there is a particular distance which creates a difference of 20 minutes. That is what we need to find out. So when the distance increases, when a person moves at 60 and 40, the difference in the time taken will also increase. So they are in proportion, right? There is no need of thinking all this. So when 120 kilometers is a distance, difference in the time taken is 60 minutes. There is a particular distance which creates a difference of 20 minutes. So 60 by 3 gives you 20. In the same way, we have to do 120 by 3. So 40 kilometers, option B will be the correct answer. So 60 by 3 gives you 20. Likewise, you have to do 120 by 3. As simple as that. So I'll just explain this one more time. I'm assuming a distance. You can assume any distance you feel like. I'm assuming 120 as a total distance. If a person moves at 60, the time taken will be 120 by 60, distance by speed, 2 hours. If a person moves at 40, the time taken will be 120 by 43 hours. Now what is the difference in the time taken now? It is 60 minutes. So if distance is 120, difference in the time taken is 60 minutes. In this case, what is the difference in the time taken? Initially he reaches 10 minutes early, second time he reaches 10 minutes late. So difference in the time taken is 20 minutes. So what distance creates a difference of 20 minutes? If 120 is a distance, difference in the time taken is 60 minutes. If 20 is the difference, what is the corresponding distance? 60 by 3 gives you 20. Likewise, you have to do 120 by 3, which is 40. You can actually find the answer uh, in a in actually a single step actually, if you do this way. So option B will be the correct answer. I think this is clear for you. Now we are moving on to the concept of average speed. I think most of you know what average speed is. So what is average speed? So imagine you are moving from a city to another city. You cannot move at a constant speed throughout, right? So in between there will be traffic jams, there will be traffic lights. So you might be moving at a very less speed in the traffic jams. Imagine you got an open road, you might be moving at a very high speed. Imagine you got a break in between, you might be like reducing your speed to 0 at that time. So the speed varies from when you move from one point to another point. But what is the average speed? In an average, what is the speed? To find that, what we do, we'll find the total distance and we'll divide it by the total time. So imagine a person moves from A to B and then he moves from B to C. So we know the distance from A to B is 40 kilometers and distance from B to C is, let's say, 60 kilometers. And let's say the time taken is 2 hours and 3 hours correspondingly. So how can we find the average speed? We'll find the total distance, that is 100 kilometers, and we'll find the total time, that is 5 hours. So total distance is 40 plus 60, 100. Total time taken is 2 hours plus 3 hours, that is 5 hours. So average speed will be total distance divided by total time, which is 100 by 2, which is 20 kilometers per hour. So average speed for the whole journey will be 20 kilometers per hour. So just find the total distance and divide it by the total time, you will get the average speed. Now instead of time, in certain questions, what you get is not the time. Instead of this, they will give us the speed. So for example, they will say a person moves from A to B, distance is 40 kilometers, and let's say the speed is 20 kilometers per hour. Then they will say a person moves from B to C at a speed of 30 kilometers per hour. Now what we have to find out, we have to find this time taken in each stretch. So initially he moves 40 at a speed of 20, so time taken in initial stretch is 40 by 20, 2 hours, right? Distance by speed. In the second stretch it is 60 by 30, 2 hours. So what is the total distance? So average speed is total distance by total time. So what is the total distance? 40 plus 60, that is 100. And what is the total time taken? 2 hours plus 2 hours, which is 4 hours. So total distance by total time will be 100 by 4, which is 25 kilometers per hour. So 25 kilometers per hour will be the average speed. So I believe this is clear for you. Now there are two situations where we can actually make use of a formula. So in certain questions, in this question which we just did, we know the exact total distance and we know the exact total time, and that's how we divided those two and found the average speed. But in certain questions we have no clue, we might not get a clue what the total distance and total time is. So I'm going to explain two such situations. One is, let's say a person travels a particular distance d1 at a speed of s1 and the same distance, so I'm assuming it as d so that you understand that the distance is same. So a person travels d at a speed of s1 and then again d at a speed of s2. So we need to find the average speed. So how can we find the average speed? Average speed is total distance by total time, right? So we have no clue what the time is, but we know that distance is same in each stretch. So distance is constant. So total distance is d plus d. So average speed is total distance by total time. So total distance is d plus d, that is 2d, and total time taken is d by s1 plus d by s2. Now what can we do? We can take d common into 1 by s1 plus 1 by s2. Now what can we do? We can cancel d off. Now when you solve this, we'll get 2 s1 s2 by s1 plus s2. Now there is no need of knowing all this. All you need to know is only one thing. If distance is constant, average speed equals, if distance is constant, average speed equals 2 S1 S2 by S1 plus S2. If a person travels same distance at two different speeds, average speed can be found directly from this formula. Okay, so likewise, if time is constant, so let's say a person travels a particular distance d1 at a speed of s1 and then d2 at a speed of s2, but time taken is same in each stretch. So if time is constant, what will be the average speed? So what we know the total distance is d1 plus d2. So average speed is total distance, that is d1 plus d2 by total time, right? Which is t plus t, that is 2t. And what is d1? Distance is speed into time. So it is s1t plus s2t, right? That is the total distance divided by the total time 2t. Now you can take t common. So we'll get s1 plus s2 all divided by 2t. We can cancel t off. So what is going to be the average speed? It's nothing but s1 plus s2 by 2. So average speed is s1 plus s2 by 2 when time is constant. So there is no need of like knowing all this, you just need to know this formula only. That is, if time is constant, average speed equals s1 plus s2 by 2. If distance is constant, average speed becomes 2 s1 s2 by s1 plus s2. So this is more than enough. So if you know these two formulas, you can actually do all the questions connected to these concepts. If they might indirectly tell the time is constant and what is the average speed. They might indirectly tell us what is the if distance is constant, what is the average speed. So we are going to do two questions connected to the same right now. We are going to make use of these equations. What is this question all about? A person travels from his home to office at a speed of 40 and returns back at a speed of 60. What is the average speed? So let's see how we can actually do this. So a person travels from home to office at a speed of 40 and returns back at a speed of 60. We need to find the average speed. So what is constant in this case? Distance is constant, right? So if distance is constant, average speed equals, we know a formula. What is average speed? 2 s1 s2 by s1 plus s2. So is distance constant in this case? A person travels from home to office and then returns back from office to home. So he travels a particular distance and he moves the same distance back. So what is constant? Distance is constant. So if distance is constant, average speed equals 2 s1 s2 by s1 plus s2, which is 2 into 40 into 60 by 40 plus 60, which is 100. So when you solve this, we'll get 2 into 40 into 60 by 100. So when you cancel the zeros off, so we'll get 24 into 2, which is 48. So average speed for the whole journey will be 48 kilometers per hour. So why are we using this formula? Because he's traveling the same distance. He moves from towards office and he returns back. So if he travels the same distance at two different speeds, average speed will be 2 s1 s2 by s1 plus s2. I believe this is clear. Now let's look at another question. A person travels from his home to office at 9 a.m. at a speed of 40 and reaches at 11 a.m. Then he went from office to market at 12 p.m. and at a speed of 60 and reaches at 2 p.m. Okay, let's see how we can actually do this. Say a person went from his home to office at 9 a.m. and then he reaches at 11 a.m. and he is moving at a speed of 40. Then he moves from office to market. He moves from office to market at a speed of 60. So he left office at 12 p.m. and reaches at 2 p.m. And for moving that stretch, he is moving at a speed of 60 kilometers per hour. So what is constant in this case? He moves from home to office at a speed of 40, then office to market at a speed of 60. And he left at 9 a.m. and reaches at 11 a.m. So what is the time taken to move the first stretch? 9 to 11, that is 2 hours. So 2 hours is what he takes to cover the first stretch. Then from office to market, he left at 12 and reaches at 2. So that means again he's taking 2 hours, right? So the time taken to move from home to office is 2 hours. Time taken to move from office to market is also 2 hours. So what is constant? Time is constant. So if time is constant, what is the average speed? It is nothing but s1 plus s2 by 2, right? So in this case, 2 hours is what he takes in each stretch. So time taken is constant. So average speed will be 40 plus 60 by 2, which is nothing but 100 by 2, which is 50 kilometers per hour. So since the distance, no, not distance, the time taken is constant, right? So if time is constant, the average speed will be S1 plus S2 by 2. We are directly using the formula. So 40 plus 60 by 2, 50 kilometers per hour will be the average speed. So if distance is constant, we'll use the formula 2 S1 S2 by S1 plus S2. If time is constant, we'll use the formula S1 plus S2 by 2 to find the average speed. So basically, what we did today is all about the basic formula first of all, that is distance equals speed into time. Then we did some questions based on the same. Then we moved to the concept of average speed. So in average speed, there are two formulas. One is S1 plus S2 by 2. When time is constant, we'll use that formula. And the other formula is 2 S1 S2 by S1 plus S2. We'll use that formula when distance is constant. So I hope you understood all the questions and all the concepts. We'll meet again in the next session. Thank you so much. Bye-bye.